Okay.
I think he said that in class he's like putting the answers stickily somewhere.
On the quiz?
Yeah. Do you think it's heavy yet?
No.
Oh, just like, okay. Yeah.
Oh, it's Dave. Okay.
That's weird.
That happened on Monday too. That we say. You guys have specific questions you want to go over?
Yeah.
Topics, okay, questions on the from the practice test or from the homework? Practice test, which one?
Not the one he gave us answers for.
Yeah, this one. Okay.
Oh, and yeah, and there's also the extra credit one. I think there's
Extra credit one? Where?
It's not on the one he gave me.
Yeah.
Where you get it? Extra credit one.
But
It's not a separate thing, it's
We
just a
did.
question on the test.
Yeah. I don't know how to credit.
yeah, let me open this one. Folder from yesterday. So we went over that question. Okay. Did we go over that question? Maybe we didn't. Never mind. Apparently we went over it without writing it down.
Right here.
So you have a car, traveling in a circle. On a track. Has velocity that way. The radius. R. And you're asked for, oh, and it says the cars driving on the track face inward at an angle of,
Yeah. I wasn't sure how to draw
is
that.
that like the track is like this? Right?
Yeah, that's what I was thinking.
Yeah, that's what that means.
I think so.
So the velocity is like into the board. Yeah. Okay. 60. Cars driving that way. And you're asked to find okay, for it not flipping.
Yeah.
Okay. So how would you start this problem?
I have no idea.
No idea?
Where did the angle of 60 come from?
It's
I'm
not 60.
Oh, okay. I was like,
Just
I don't
It
know
was
where.
angle B, and for some reason in my head that translated to 60.
Oh, so this is the
Yeah.
fold that's between them, right?
Yeah, that's the one that you gave me.
Hey, you got it.
Hello. So So, does anyone have an idea of how they would start this problem?
What's the?
It's the extra credit problem on the. I know the practice test without answers.
So they're asking for the maximum velocity?
They're asking for.
Yeah.
Yeah.
And what values do you have?
You don't have any values, right? Or no,
Yeah.
it does give you.
It gives you, it says R.
If radius is 45 meters. Yeah.
Where I was confused is like, if you don't have friction, how would you know, like, what point you need to go past to not split?
Oh, there's friction.
Friction is going off the trail, right?
In terms of the static frictional coefficient between the towers and the road.
Oh, okay.
Yeah.
So there's friction?
There is friction. So I'd start by drawing the car, or like the different forces acting on the car, right? So, yep. You have the circle. Well, we really need to do this in 3 dimensions. So that's what makes this problem hard, right? Up, down, left, right. Not really 3. We'll draw it this way. Like this is the car. We're just not going to be able to draw the velocity. The velocity is in the forward. So what are the forces acting on the car?
No. But why is it on the machine?
That's the bank of the track. So this
Oh, okay.
incline like goes
Because
in
it's
a
going
circle,
in, okay.
right? So it's like this is a smaller. Yeah, so it's like, and then he's going around the circle.
That's fine.
Yeah.
Does
Okay.
picture make sense? I don't know. We could look up a picture from fake racetrack. That would help. Or can you all visualize?
Yeah, wait, I have a question.
The part, okay. So, what forces are acting on the car?
There's gravity, there's friction.
There's the same. Yeah, gravity. Friction. Which way would friction be acting?
The
There's the moving force, yeah.
right.
To the left, right? Friction.
Yeah.
Okay.
Wait is the car?
Yeah, that's gravity.
Oh, okay.
Okay. Yeah, that makes sense. Friction's acting on. Which way is it accelerating?
To the center.
Towards the center.
To the center.
This way. So, which is going to be v squared over r, right? So, let's solve the force. What direction do you want to sum everything up in? Or where do you want to draw the x and y?
Like this.
For the horizontal direction. Makes sense. Future, either in terms of the.
You can really choose. I would choose it in the same direction as one of your forces. But honestly, these are perpendicular and these are perpendicular, so it doesn't matter which way you draw it. If that makes sense.
Yeah.
Because the direction you draw your and y-axis, you want it to line up with the most forces possible. And in this case, if you drew it like this, you have two forces. If you drew it like this, you have a force in the acceleration, which is just as good.
I was thinking because it asks for it in terms of the side frictional coefficient.
Mm-hmm. So you want to do it this way?
Yeah.
Okay. Okay. So which one do you want to sum up? X.
One thing, what are we looking for?
We're looking for
Maximum.
velocity. So what's this equal?
Force of friction minus acceleration.
Okay. Wait, what? Force of friction minus. This is the acceleration, not a force.
Oh, okay.
Right? So that's why it's dash. But you would subtract
Times gravity.
G
Sine theta.
theta. And this is also going to equal mass times acceleration, which is going to be g squared for r.
Well, what equals mv squared over r?
MA, A centrifugal, is g squared over r.
Oh, okay.
Because it's going in a circle.
Yeah.
So we have this.
One question, what's the value of the normal in this particular example?
We haven't solved for the value of it.
Okay, but how do you get it?
You would sum up the forces in the y direction. G equal to
The normal minus.
normal force minus mg
And that equals 7.
is going to equal MA, but
It's a
y direction. So you're going to have okay, not that much noise. And then so since the color is not withdrawn, it is in the y direction or the x direction,
Yeah.
technically. So here,
So we have to break the
Yeah,
acceleration into
we have
components
to-
too.
break the acceleration into components too if we're going to use this acceleration.
Okay.
Okay, we just towards the center of the circle. This for the x, we
Because it only asks like to derive the
Is it
formula.
going at a constant
yeah.
speed?
It says they experience centrifugal acceleration, so I'm guessing.
Yeah.
It should be. Yeah.
It's,
Yeah.
so you would use these two formulas, and that this is equal to mu
K
k. Yeah. So you would use these to solve for v.
We don't have the value for mu k.
Yeah. In terms of.
Well, just derive the formula.
Mm-hmm.
All right.
Do you know?
No.
Yeah.
Well, actually, mass is going to end up being in
I can't do that.
everything. Yeah,
Yeah.
mass will cancel out. And you know R, no G. You're solving for G. And it's
But
just
you don't
in
know
terms of Newton. So.
Yeah. But you don't know what it is.
No, we don't. I would assume it will either drop out or you'll be able to just leave it in terms of theta too. theta b as well. Yeah. There's a bunch of people, okay. So, would you like to finish this problem, or would you
Yeah,
like
let's
the next
finish it.
one?
Yeah.
Finish this one? Okay. So, I'm going to copy this onto a different page. Okay. So for this, we'll solve for the normal force here. Normal force is going to equal mv squared over r sine beta b plus mg cosine b. So you plug that in this equation. So you're going to get UK times b squared over r sine beta plus cosine minus mg sine beta is equal to b squared over r cosine theta. And here is where you get all the m's to drop out. Copy this again. And you get b squared r sine beta b plus b squared over r cosine theta b would be equal to g sine theta minus g cosine theta. So to divide all of this, multiply everything by r, divide by the rest of this, get b squared r g sine theta b minus r g cosine theta b over UK sine theta b. Oh wait, something. This is UK. G cosine RG. Would be b squared. So b would be the square root of all of that, which is super fun. You could simplify it, but
Yeah.
that's time. So be easier to just yeah. It would probably be more productive for us to go to the next thing, right? Any specific questions on that, other than the extra credit one?
Are you gonna ever just
other test. That's both of them.
The first one, part B, on the fall test, doesn't make sense even to people who took the fall test. So, yeah.
Okay, wait. This
I asked
is
some
the
people
fall
who took the
test?
fall test, and they were trying to look at his answer key, and they were like, where did he come up with this?
Oh, this one?
Yeah.
Okay.
Basically,
There's-
just to like substitute units.
I don't know where the 35.6 came
Is that the
from.
velocity square?
I don't,
Where does it take
35.6 over 9. So I get that 1g, it's
Yeah.
200, and that's with no velocity. But now we have velocity, and everything changes, and I cannot figure out for the life of me where the 35.6 comes from.
Okay, so you need to convert this into kilograms.
But he says that you don't.
You don't.
Yeah,
The conversion
that's
from
the
pounds to
confusing part.
newtons or kilograms does not mean that they answer this question.
So
Oh, well, okay. Let's see if we can do it that way. Yesterday we did it the other way.
Yeah,
I'm
after I
going
converted, I got
to-
his answer.
Snip this. And we're just not going to look at how he did it and figure out how to do it in a way that makes sense. If that doesn't make sense. Okay. Here we'll turn on person feel the bottom of the circle. Let's do everything in terms of M and G in the variables instead of plugging numbers in. That will probably help. So at the bottom of the circle, he has the velocity, there's a radius to the center. Right, acceleration is going to equal v squared over r, as always. Your person, you can ignore the car because it just asks about the person, has a normal force from his seat in the car, is mg down, and he's accelerating towards the center of the circle. So, if we sum up the forces, we get normal force times or minus mg is going to be equal to mac, which is equal to mv squared over r. So we can get normal force is equal to v squared over r plus mg. So what would the scale be? What would I strap it under? Well, how heavy would the person feel? So this is going to end up being,
If you ever have any questions, like how heavy would someone feel, are you just trying to
if you're
calculate the
always
normal?
figuring out the normal force, because the force is what you feel. But here, it's asking how heavy would the person feel. So I think the reason that you can discount mass is it's asking how much mass do they feel like they have, right? So what you're solving for is normally when you're standing on the ground, you don't have any velocity in one direction or whatever. So you feel mg as your normal force. So I'm not explaining this very well, but I would set normal force. Let's just plug in some numbers. I'll kind of figure out a way to explain what I'm thinking. So for this, it's going to be m times v squared over r plus g. So they're going to feel heavier than normal.
Yeah.
Right? and they're going to feel heavier than normal by a factor of v squared over r. So normally they feel mg. Now they feel v squared over r plus g.
So that's why the units don't matter.
Yeah, that's why the units don't matter. You can make this into a ratio and figure out how the mass they feel like they have changes based off of the change in the acceleration. So basically plug in mg for n, I think. And then you could find, that's not quite what I mean. Because you need to solve for m, and then m would divide out. Don't want m to divide out. So this is going to be m nu. I think that's how I would do it. We'll see if this gets us the right answer. So how much did he weigh?
200 pounds.
How fast is he going?
14%.
9 something.
98
9.8
squared.
squared. What's the radius?
8.7.
Did you say random numbers? Plus 9.81 over 9.81, and the units of all of these are going to cancel out because you're going to have meters per second squared over meters per second squared. So then you'll be left with pounds. So then you wouldn't have to do the conversion that way. Does that get you the right answer? Yeah?
I mean,
Okay.
that's the 35 part. I just,
Okay. Do you
So
want
that
me?
gives you the right answer?
Yes. So I'll figure out if I can explain what I did. and
What's wrong with
say-
just converting? Why is that? Like,
Nothing's
you
wrong
just
with
trying to
just
prove that you don't
converting.
need to know that it's a ratio. That's
Yeah,
the point of it.
I guess this is the point to think about why you don't need to convert and to, yeah, it's just a ratio. And I think the wording of the question is confusing because it just says heavy, and if you think the word heavy can usually be taken to mean the mass or the weight, which are different things. You're looking for the weight, which is what I would have normally assumed from looking at this problem. I would have solved for a normal force, and I would have needed to convert the mass. But it turns out he's actually asking for how massive does a person feel. So you're solving for the mass felt instead of actual mass.
So that mg now,
Yeah.
it's the normal force at that moment?
Yes, mg, this I should really write m felt, but the mass felt times g is the full force. It's also when they talk about like experiencing, say, like 2Gs or 3Gs. That's what this is like. 2 times your normal mass times G is what they're saying. Why is it N mg? Why is N and G when both N and AC are in the same direction? And mg isn't N minus mg. Wait. Why is it N minus mg? Because that's why. But yeah. We defined up as positive, so N is positive, down is going to be negative, AC is going to be positive because it's up. That's why it's N minus mg for the total force.
Because AC is not like
Yeah.
what we don't subtract.
Yeah.
I think that's
AC is the total force. Total. Yeah.
Can you do B on number 2?
B for number 2. Okay. Y is the Y component.
Oh, not on the
of
other
what?
test.
The other test. This test.
Yeah.
Okay. I think we did this yesterday.
The way it's set up looks weird.
Okay.
I hated the wording of part C of this one. There's like, don't throw out everything and just have it be flat. I wasn't sure if the acceleration stayed.
It's still there, yeah.
Yeah. Okay.
And why not just say how we have it
Super. Okay, so you have box on an incline, and there's a with friction, and it does accelerate. It says kinetic friction. Okay. So part B, you said?
Yeah.
Okay. So 632. You have your box. How would you start the problem?
So drawing a free body diagram.
Yeah. So have your point. What forces are there?
So to the right, there's a force of friction.
Yeah. Okay.
And then up is the normal force. And then the 2 components of gravity, so
Yeah. So there's
mg
mg.
inside.
Yeah.
Is the normal force not perpendicular?
Maybe we should look.
It is. This is the surface. Wait, no. I did do that wrong. You're right. Normal force is perpendicular. Yeah. Anything else?
That's it.
Yeah. I usually draw in which way it's accelerating, but sometimes I'm fine. So it's asking for the coefficient of friction. So where would you start?
So I drew the force in the x and y direction.
Mm-hmm. So I start with y just because we're going to use the normal force to solve for friction. Normal force minus mg.
Those.
Yeah. It's going to be 0. So force is equal to mg cosine of the angle, which is 32. Yeah. So you can solve for that. So the force is x. It's going to be frictional force, which is u k n.
Wait, where does it equal 0? Up there.
Up here?
Yeah.
Because it's not up or down.
Oh, okay.
Here it's going to equal the
The acceleration, okay.
Yeah. Minus mg sine of the angle is going to equal ma. So,
And then plug in that n that you got there and solve for
And-
UK.
yeah. So, any questions about part B? Or how do you finish it?
Can you do C just in case?
Do you see?
Yeah.
Okay. Right. Okay, now assume the ramp is replaced with a flat horizontal cable with µs double µk. What is the static force of friction on the block now? So you have flat table, box, M, you have µs equals to 2 µk from the previous problem, and I'm going to assume it's still accelerating. No, it's not accelerating, so it's static friction.
Yes.
Which is
So-
confusing, 'cause it doesn't say that.
Yeah, I feel like that's
Think
like
of an answer to
classic
this
trick
one,
question.
It's
because
zero.
yeah, this is zero.
Yeah, it's zero.
It's not moving. There's
Is that
like
because
no
they
force
flat?
on it. Yeah, it's flat. If you look at, they're down, and
So dirty.
normal force. There's nothing, no forces in the x direction.
So it's just zero. But we have to explain it, right? So,
There's no force in the x direction. So.
Mhm.
Anything else for this test or the other test?
For 8 in the other test.
8 in the
8.
C.
Yeah.
C. What acceleration must the truck driver reduce to in order to stop the box from continuing to slide backwards? What we were talking
Yeah.
about, right?
Yeah.
Do you want to explain it?
I mean, hold on. Do I even have it anymore? That's a good question.
Yeah.
So we already found the acceleration for part B. So it needs to be, hold on, if I had it. Yeah, okay. So the acceleration has to be lower than that by quite a bit. So the acceleration has to be slow enough to not only, it has to be enough to stop the box from sliding more because it's already sliding, so it has to be enough to slow it down and stop the box. So I just set μfn equal to ma, and then crossed out the masses, and we know the coefficient of the coefficient of kinetic friction, so just multiply that by graph. It seems too simple, but
Yeah.
I mean, it's less, so it makes sense.
yeah,
Yeah,
I guess.
Okay.
that's correct.
And which mu do you use there, the static friction?
Yeah, kinetic, because it's moving.
Okay.
Yeah, so the box is moving, and we want it to stop, but it's still like until it stops. It's
What way did you use? If you're using kinetic, the coefficient of kinetic friction, how are you gonna get the acceleration?
Okay, so what you want to have is for the box to once more be accelerating the same direction as the truck, right? Instead of the opposite direction. That's why you take the new acceleration of the truck that has to slow to, set it equal to the kinetic friction.
Oh,
So that
okay.
so it completely.
Okay.
Mhm.
I thought you had to find like something else and then like minus something because
Yeah.
Yeah.
I have a question about the static friction.
Yes.
Why is it always less than or equal to?
It's always less than or equal to because the static friction is only as great as it needs to be to keep the object from moving. Kind of like in that trick question where it was static friction is equal to 0. There was no force acting on the box, so there was nothing that
6 years.
static friction needed to do. So it didn't exert a force on the box, or else the box would have just flown to the right for no reason because of friction would make no sense. So
So do you calculate that with a normal force or with a force that's in the direction?
So when you're calculating static friction problems, they'll be The wording of the question will tell you what it wants you to calculate. If the question asks for, say, like the maximum angle or maximum force without moving, then you are going to calculate static friction using US times the normal force. If it's asking what the static frictional force is, that's usually asking you to calculate the static frictional force using the other forces in the problem, because if it's asking you what the force is, it's usually not the max force.
Give an example of the second case.
The second case, there's probably one in the practice test, but just if you had a block sitting on an incline, and you just say like, what's the force of static friction given the mass of the box, given anything else that's happened in the problem.
Oh, so
I can find one in the
would it
test.
would it just be the opposite of the?
Yeah, it'd
component
just be
down
the
the ramp?
opposite of the gravitational component down the ramp would be equal to the static friction. Same with the box problem that we just did. This problem, it did ask, what is the static frictional force on the box now? It'll just give, most of the time if it asks what's the static frictional force on the box, you have an unmoving object and forces acting on it. What's the static frictional force? Does that make sense? Yeah.
Can you do the last one on the one without answers?
The last one on the one without answers.
The one with the gravity intersection?
Yeah. Just a second. Last one. On your first attempt.
Ooh.
Oh, this is the problem.
We're gonna have.
I think it's gonna,
Yes, I'll be.
I think we're gonna have this answer.
Probably.
I mean, he said that like there was one similar to this in the homework, but then these two parts, he's like, oh, but these parts I expect you to be able to know.
Yeah, these are the ones.
So
Okay.
I would assume something is possible.
How far from the center of the Earth will you get? So this is a.
As far away as
Well, with this velocity. Both parts or just one part? You were asking for both, I can't remember.
One, both.
Both? Okay. So for A, you're going to use that formula where you start out with the this one, Gmn over R for gravitational energy. So
He doesn't give us G though, right?
he should.
Okay.
It's capital G.
Did we not get the radius?
We have the radius, we just don't have.
Radius is the, yeah, so I would use final. Say before you have a bit of this potential, after, it just asks you how far from the surface of the Earth, right?
Yeah.
So actually I wouldn't use this, I would use change in kinetic energy. It's going to be equal to, it's the same thing. Change in potential energy, so you're going to have from this speed to 0, and then from radius of the Earth to further. So you have G M over R1 plus 1/2 M V squared, and that's G over R2. And you're going to want to solve for R2 minus R1 because it asks for, oh wait, never mind. It asks for from the center of the Earth, so you do want to solve for R2. R1 is the radius of the Earth.
In R2.
R2 is how far you get from the center of the
So
Earth.
that's what we're looking
Yeah,
for.
this is what you're looking for. This G is the gravitational constant or something like that.
So you don't have to. You don't have to
It should
take
be
it.
on the formula.
Yeah,
Mm-hmm.
6.6 times.
Yeah, 6.67 times 10 to negative 11 a log units, Newton meters squared per kilogram squared.
So do you not need to take into the potential energy of the moon?
You don't unless you get really close to the moon. He said that in
Isn't that
class.
what was the problem with the physics homework? Is that part of the calculate?
Yeah. Yeah.
So we only calculated that.
Yeah. If you want to escape here, it's going to be completely. Yeah. This is. Yeah. If he escaped.
One
Did
thing.
anybody even calculate that for you?
What's which formula? Or
The
what's the
escape velocity formula.
Oh, that's
Yeah.
The little m doesn't matter because it always comes.
Mhm.
So the damage
The big M.
Earth in both cases. So it's the escape velocity.
See, I didn't.
The escape velocity formula is like some TGR. I could
Square
look up
to
how.
GM.
Yeah.
Oh, okay.
Because in this one, it's just, it would be, you'd start out with the velocity and the gravitational potential after the failure, so you'd end up with nothing. Because you escaped. So there's no more gravitational attraction.
For the part A,
Mm-hmm.
can you just do GMM over R plus X equals 1/2 MV squared and then solve for X?
GMM over R plus X. Like plus X on the bottom?
Yeah.
Mm,
Because
Well,
R is the
you're gonna
radius and
end
X
up-
is how far away from the radius you got. And then
yes,
equal.
it's asking how far from the center
Yeah.
you get though.
Yeah, so oh wait. So then just,
So when
yeah,
you
that's still there.
So for this, if you took this to the other side, you would get minus over R1, which like, putting R1 under here doesn't work with fractions, so no, you couldn't do that. But
For part B, do we just set the kinetic energy equal to the potential energy? That's all true. You want to know, let's see if that's so you want to know the kinetic energy with all the gravitational potential energies and stuff.
does anyone have? You'll probably go over 2 more questions.
The E and this here.
I was trying to refer.
Oh, okay.
Yeah.
Can you go to number 2 on the one without answers?
Has everyone copied down what they want from this? I can just move it. Over 2.
So I know how to find the magnitude acceleration, but how do you know the sign if it's negative or positive?
If
For-
you know the acceleration is going to the center of the circle. So if for example a cosine theta it's going to the center, and in that case it would be negative for x and y because they're both going down. Like y is going down and x is going to the left.
Oh, okay.
Mm.
Can you go to number 10?
So for example, in B, the acceleration y is positive, right? In B, the acceleration y is positive, right?
In G,
Yeah.
yes, y is positive because
Yeah.
y is up.
This is just good.
Oh, yeah.
Oh, and then x is negative because that's.
See, we just-
Yeah.
Okay.
I would just always draw the circle and just draw the arrow and its components.
Oh, okay.
Just to help you visualize it, because then you can't really mess up at all. It's kind of difficult.
So in that case, y is positive and x is negative.
Yeah,
Okay.
right there.
For what you said about 11, with that, are you calculating the final speed, or are you calculating the initial speed in order to escape?
For part A or part B? For part B, you're calculating the initial speed.
Okay. So does that still work if you set the final kinetic energy equal to the initial?
Yes.
Because wouldn't that be the final?
For part B, where did I put all of the markers? For B, you have initial kinetic energy plus final, or initial energy plus final energy, or equals final energy, sorry. What am I even saying right now? So initially, you're going to have kinetic energy plus the gravitational potential energy. And finally, it doesn't say that you need to still have speed after you escape, so you can just assume that everything is zero after.
Oh, wow. That makes it.
Yeah. Yeah, because it doesn't it's speed, so I would assume what minimum speed. So to use up all of the energy. Someone said number 10. Number 10.
It was easy, but I got confused.
Is it B?
Yeah, that's what I thought.
Potential energy U of some objects as a function of x looks like plot shown below, which value of x shown is the magnitude of the force on the object smallest. So,
Is it B?
yeah.
Because it's
So it
related, right?
corresponds to the derivative.
That's correct.
And if they ask which one is the biggest, in this case it will be A.
Magnitude.
Depending if it's positive
Yeah.
or negative.
Well, if
It
they
would
ask
it would
for
just be A because it's negative. Like it's a negative integral. I think. Where's this formula?
I think it's the negative derivative, isn't it?
Oh,
It's a negative.
Oh, integral. Oh.
So if they ask for the largest magnitude, they ask for the largest.
Yeah, to calculate the force, you would do
The largest portion would be C, right?
the derivative.
Derivative.
Of force. The
Yeah, yeah.
energy is the integral. Yeah, you know.
So I think he did like du of x equals like negative f of x.
Yeah.
And what about, for example, the magnitude of force is the biggest in the negative direction?
Yeah.
That would be,
Which one of those is the
That would
biggest in the negative?
be C.
Because it's going that way.
Yeah.
oh, the negative.
So in the negative direction will be C, right?
Mhm.
Okay.
Yes.
Wait, so it's negative slope.
Yes.
Oh, okay.
I think so.
Okay.
I remember that being when you went over it in class, if there was a negative sign.
Yeah.
In-
I remember.
Yeah,
C,
so it's
C
negative.
is negative.
So
Yeah.
C is going up, so
So
And
yeah,
then-
C has a positive slope, so the force would be negative.
And A has a negative slope, so the word is positive.
Yes.
Okay.
so C will be the negative direction.
Yeah.
That's pretty.
Yeah.
Can we do one?
Yes.
The choice one. 5 on, I think it's this one.
The same one. This one?
No,
Other time. This one.
Yeah.
Okay. Okay. Object. This one is object one.
So how is it case 1 and case 3?
Just use the equations. Right. So in case 1, its kinetic energy is going to be equal to the change of potential. So it's going to be G over. It starts at 2R minus G M over R. As in case 2. This is going to equal to 1/2 minus 1 is going to be more negative G M over
What does the
2R.
second term represent?
Here,
No, term after that.
that's a R. This is the final. Initial minus final is change.
Why is it 2R? Okay.
It was originally like from the radius, from the center of the earth.
Oh, to
It
here.
was, yeah,
Okay.
here's 2R.
Okay.
And the second is R.
So it's the changing rotation.
And then for case 2, yeah, kinetic energy equal to, let's start out, equal to 3 Earth radius. GM over 3R minus GM over R is going to be minus 2/3 GM over R. So case compare kinetic energy of the two objects. So 2/3 K3 is going to be equal to 1/2 K2. No, wait, the other way. Okay. So if you multiply each side by, like, if you multiply both sides by 3/2, you'd have K3 is equal to negative GMM over R. That would be 3/2 K3. Here, it would be 2. Oh, I got.
I don't think that's right.
Right. Here, you broke that. You circled the other one. Compare the kinetic energy just before I did this. One. Okay, so right here he wrote it out, and he got 3/4.
4/3?
Case 2.
Case 2 is going to be 4.
Oh wait, it should be 4R instead of 3R.
4R.
Yeah, 4 right down there.
4R down here.
No, the other side.
On the other
Case 2
side?
first term. Because it's 3 Earth radii above the surface.
Oh, yes.
Yeah.
Thank you. 4r. So this is 3/4. So this is 4/3. Yeah. Yeah, that's right. Okay, one.
Yeah, yeah.
Does that make sense? What if you're doing your own?
Did we already do the carnival ride or the roller coaster?
No.
We didn't really showing nobody else wants.
Let me check.
Carnival questions in general.
Yeah.
Mm,
Where? Which test is that one on?
The
no.
no answer.
The no answer test. Okay. This one?
Yeah.
Okay. Okay. Which part? The whole thing?
Yeah.
Okay. Classic carnival ride. Savings along. So you're given a radius and a frequency. What is the speed of the person stuck to the wall? So that you have frequency is equal to 7 revolutions per minute. And you're going to need to convert this into meters per second. Yeah. So how would you start out that?
Divided by 60.
Okay.
Wait, divided into what?
No.
Yeah.
Divided.
Oh, yeah.
Yeah, 2 seconds on the bottom. And then, revolutions on the bottom. So
Does revolution go to the bottom?
let's start down on top, so you don't want to have revolutions on the bottom, and whatever revolution is equal to in meters on the top.
Oh, so the diameter of the
Circumference.
The circumference.
circumference.
So that's
2 pi.
2 pi.
2 pi
Wait,
times 6.7 meters. And then you get something in meters per second.
That's just the velocity.
yeah.
Yeah.
Right.
You guys get 14.
And the normal force, what's the normal force?
Normal force in the wall, the mass of the rider. Okay. So you have this person, it's a normal force. There's the frictional force, and there's gravity, and it's accelerating this way. So, how would you start to find the normal force?
Sum of forces on x.
Yeah. Is equal to,
And then equals an A.
yeah. What's A equal to?
B squared over R. Okay.
And we just have all of those.
Yeah. You just solve for B and give it.
Is the circumference 2 pi r or 2 pi?
2 pi D. 2 pi.
5B. So that's 4 pi.
Wait, 2 pi. Is it 2 pi r?
No, 2 pi D.
Yeah, 2 pi r. And what's the?
Yeah,
No, it's just,
It's
it's
2 pi.
2 pi r.
It's 2 pi r. What's 2 pi r?
What are you talking about?
Oh, of course, of course. It's pi D, not 2 pi.
Yeah, it's
pi r.
5B equals 2 pi r.
Yeah.
It's straight
Yeah,
regular
yeah.
diameter, and
Can you prove that?
pretty curved. Yeah. I hope you don't actually. Yeah.
I hope they ask this in the exam.
Yeah, it doesn't actually
That's one of the
questions.
What is the conference of the city?
Calculate a generalizable formula for the.
So we're gonna have a equation sheet, right? Okay, that's good.
Was
Yes.
it 15,000 something?
Yeah.
But
1,500.
1,000.
Oh, okay. So we're done now.
Right. Thank you.
No, un poco más.
Por ejemplo, solución no es fail. Empezar a respuesta.
Oh my god.
¿Qué? No tengo idea.
Can I get the?